All right, honors geometry students, let's talk about interior angles. So if we look at the diagram here, an interior angle is formed by two chords such that the intersection of the two chords is inside of the circle. So the vertex of an interior angle formed by two chords is inside the circle. So let's say that we have chord AC and we have chord BD, and let's say that they meet at point E. Okay. What we're going to prove is the relationship between an interior angle of a circle and the arcs plural that it forms, because if we call this angle theta, so if we call angle AEB theta, it's an interior angle. It's responsible for two arcs because of its vertical angle. So if that angle is theta, then this angle down here would also be theta. And if you kind of look at the interior angle up top, angle AEB is responsible for arc AB. So that's one of its intercepted arcs. And if you look at its vertical angle is responsible for arc DC. So what we are going to prove is the relationship that you maybe saw in the Notice and Wonder on the worksheet today between the interior angle and the two arcs that it creates. Hopefully from the Notice and Wonder, you noticed that theta should be equal to the measure of arc 1 plus the measure of arc 2 divided by 2. So what we're going to try to do here is prove that, well, not try to do, what we're going to do here is prove that so you understand why that relationship exists. So just like the problem above when we did inscribed angles, we related it back to what we knew. So what we're going to do here is relate this back to an inscribed angle. So if you don't understand an inscribed angle, this proof might not make sense to you. We need to really understand how an inscribed angle relates to the arc that it creates. So what I'm going to do is I'm going to draw in a couple of extra chords here. I'm going to draw in chord AD. And when I draw in chord AD, I've created an inscribed angle. If I look, angle DAC creates arc DC. So if arc DC was X, then angle DAC has to be half of X because of what we proved above. The inscribed angle is half of the arc it creates. But what's really, really interesting about that is if I draw in chord BC, I've created another inscribed angle, angle CBD. CBD is an inscribed angle. What's cool is that it also creates the same arc. Look, angle, if you kind of use your hands to cover up, that inscribed angle makes arc DC. Well, if arc DC is X, then this inscribed angle must be half of X. So those two angles are congruent to each other because they're both responsible for the same intercepted arc. So if you kind of use your hands to cover up, there's an inscribed angle that made arc DC. So since arc DC is X, the inscribed angle is half of X. Here's another inscribed angle that made arc DC, which is X. So that inscribed angle must be half of X. If I look on the other side of things, and I look at inscribed angle, angle ADB, angle ADB is an inscribed angle and it creates arc AB. So if I call arc AB Y, then angle ADB must be half of Y. And if I call, once again, if I go to this other location, angle ACB is inscribed and it's also creating the same arc. It's created arc AB. So if arc AB is Y, then angle ACB must be half of Y. So our goal is to show that the interior angle, which we marked as theta, is equal to X plus Y divided by 2. Right? So let's see how we can do that. Well, identifying theta's supplement is going to be helpful. So if this is theta, then this angle is 180 minus theta. Well, the three angles of triangle ADE have to add up to 180. If I used triangle BEC, I'd be in the same boat because the vertical angles are congruent, right? So this angle is also supplementary to theta, so it'd have to be 180 minus theta. So all I'm going to do now is add the three angles of triangle AED together, and they should sum to 180. So let's see what happens there. I'm going to take 1/2 of x plus 1/2 of y plus 180 minus theta, and that should be equal to 180 because those three angles of the triangle have to sum to 180. Well, I have a 180 on the left side of the equation and a 180 on the right side of the equation. And I want to solve for theta, so I'm going to move theta to the other side. All right, if I subtract 180 from both sides, the 180 simplified to 0. If I add theta to the other side of the equation, I now have theta is equal to 1/2 of x plus 1/2 of y. Okay, well, if I'm kind of creative, multiplying by half is the same as dividing by 2. So some people like to say that this is the same thing as x plus y divided by 2. Others like to just factor out the 1/2 and say theta is equal to 1/2 of x plus y, right? We're saying the same thing here. I like either one, but I like to put it into just everyday language. X plus y divided by 2, that's how you find an average. So I just say theta is equal to the average of the arcs because x is one arc and y is the other arc. So when I write it out in words, the measure of the interior angles is equal to the measure of arc 1 plus the measure of arc 2 divided by 2, or in everyday language, okay, well, this is the same as 1/2 the measure of arc 1 plus the measure of arc 2. Okay, so that's another way we could write it, equivalent to one another. In everyday language, I just say that the measure of the interior angles is equal to the average of the intercepted arcs. Average of the two intercepted arcs. I hope that's helpful.